Morning to you all. Today we are going to be discuss about intelligent agents. The name implied that intelligence needs knowledge. Knowledge comes from information. Information comes from original data. Whereas the agent is the program written to do the task specified. So here the intention of intelligent agents is to build the program to solve the given problem and to produce the solutions which are more acceptable and accurate for the end user. The outline of discussion about intelligent agents is, in shortly, it is a PAGE, where P stands for perceptions, A stands for actions, G stands for goals, and E stands for environment, in which the perception indicates observations done in the environment where we are going to be take the problem and solving the problem and submitting the result to the same. Actions means what we are doing in order to convert the input to the output specified. Goals is to say that how the output is generated and the objective is met. Environment is the place, the physical location, or the problem definition where the needed inputs are observed and resources are identified to convert the given problem into a solution. Where environment types to be discussed, agent functions and programs to be emphasized, the types of agents to be differentiated in a detailed manner, and along with the real world example for the same. First, the page where page P stands for percepts, that gives what perception we could do, what we could see, what we could listen, how will we conversate with the environment, and actions defines the verb and the operators to be done to convert the given input to into a new state, from there to the goal state. The goals are the endpoint of the given problem. The environment that defines where we are working, and the environment defines what we have taken as inputs, how you represented, and how you utilized to convert a question into answer, a problem into a solution. Here, but the percepts is maybe video, maybe accelerators, the gauges, engine sensors, and keyboards for the global positioning system. If we are talking about the real-time application called the automated taxi, and actions are possible for the same automated taxi application are the steer, accelerate, the brake apply, horn uses, the speak and display of the content on the specified boards. And the goals mentioned for automated taxi specified as safety journey, reach the destination within a stipulated constraint, maximize the profit of reaching the goal, and obey the law specified for the navigation and the passenger comfort for the same application. Where environment defined for the automated taxi application as what are the paths that are mentioned, what are the freeways are specified, the traffic rules to be followed, pedestrians to be observed and need to provide the space for them, weather conditions, and finally the satisfactory level of the customer to have a great journey and happiness also. For internet shopping agent, what are the perceptions, actions, goals, and environment can be specified so that we can see with respect to the given domain, where the rational may not be omniscient in the sense that may not be the expert having the skills in all the required problem parameters. The rational may not be the clairvoyant, the rational may not be the successful, but the here we have the provision to learn to make it complete, to make it success. So without loss of generality, the goal specified by the performance measure that define the numerical value for the environment where the problem solving takes place. So here rational actions are Whichever action maximizes the expected value of the performance measure, it given the perfect sequence of date in the sense that so how you are performing the action, what is the outcome from them, and what is the accuracy of that outcome. That outcome must able to produce the maximum profit for the end user. So if you take the environment types with respect to the various parameters that are accessible or not, deterministic or not, episodic or not, static or dynamic, discrete or continuous. So, in the sense of environment, respect to the various applications like solitary, backgammon game, internet shopping, and automated taxi are different. In what way they are differ? Here we are going to be map real-time applications with the types of environments. So our applications are mentioned solitary, backgammon game, internet shopping, automated taxi are trying to map with the environment types with respect to the accessible or inaccessible, deterministic or undeterministic, episodic or continuous, static or dynamic, see discrete levels. So here, if you see the automated taxi, the complete environment is not accessible and the navigation or the path of journey completely not deterministic, and it is not episodic. Once the started our journey from the source to the destination, we can't stop it. And what the environment we are dealing with automated taxi application is not static, it is dynamic. Along with our vehicle, we can see the other vehicles, we can see the roads, we can see the pedestrians, we can see the signals, and other things which are the part of our navigation. And the automated taxi application is not discrete and it is continuous in the way of reaching the specified goal. The environment type largely determines the agent design. The real world here it is inaccessible completely and it is stochastic, right, to be accepted, and sequential and dynamic also, and in the way of executing the environment which is continuous. So an agent is completely specified by the agent function, the mapping percept sequence to actions. So here we are trying to build a program. That program is able to read the inputs, apply the action, and produce the output towards the goal state. So one agent function is rational. That rational is the right thing we did in the right time. The aim of these programs are find a way to implement the rational agent function concisely and precisely. An agent program, it takes the single percept as input, keeps internal states and apply operators on it to reach the specified goal. Artificial intelligence is a modern approach in which we have considered the agents are the code defining types and programs, algorithms are the code for the methods used by the agent programs to convert the given input into the specified output. Environments are the place where the code defining the types and simulators, and domains specify the problem types and instances for inputs to algorithms. Here, the agent types are defined for simple reflex agents with state, goal-based agents, utility-based agents. These are the four types of agents are determined based on the domain specified and the functions you are going to be utilized. Simple reflex agents, it receives the inputs from the environment through the sensors, and that they are going to be know what the world is like now. From there, we will see these inputs are matching with the conditions and rule-based system available with us. So once our input of the environment is matching with the rules available with us in the form of knowledge-based system or rule-based system, we came to know which rule is to apply through which a current state converted into a new state and is the part of reaching the goal state. So that they mentioned as what action I should know. For example, we entered into the room and feeling hot. So we came to know whether we need to switch on to the fan or switch on to the AC if it is available. So here the environment is the room and what we perceived is that hot, and we need to decide what to be done based on the current position. So based on feeling hot in the entered room, we came to know switch on to the fan or switch on to the AC to make it cool. That's the action we need to. And that effectors are the outcome. Sensors are inputs and effectors are output. And submitting output to the same environment from which the inputs are received. Reflex agents with state indicating that to take the input from the environment and input are required to identify the what the world is like now. It be represented in the form of state, and how from that state we need to question how the world evolves, how progress it is, what is the sequence of actions are applied in the given environment, and based on the states we observed and links we observed among the states, we are able to decide what actions to be done on that. These actions can be applied based on the principle between matching the current state with the rules available with us. Once the rule is applied on the current state, we'll produce the new state that will be part of our journey to reach the goal. And that what action I should to know is defined and output is generated and submit the same to the environment. Where the goal-based agents defined as what is the goal to be reached. We need to identify what we need to do and where we need to reach. Based on that principle, this goal-based agent works, and it is differs with the previous two states with respect to the state added as what it will be like if I do action A. Means to say, if I have the environment from which inputs are received represented in the form of state, and we are able to identify evaluation of the state and what actions to be applied based on the states what we have, and we're going to be observe what it will be like if I do action, in the sense that if I have the state and the operator is applied on the same, what is the result of that, whether that result is part of my goal path or not. Based on that question, this agent works. And once we see the outcome from that, from every current state, a new state is generated, and see that how far that new state is helpful for us. And based on that one, we will see the particular rule to be applied on the current state and see the accuracy and usage of the new state in our journey, and the same we will submit to the environment as the outcome. In the base of utility-based agent, utility is mentioned as the facility. It is given to that where the one more state is added, that how the customer or end user is happy with the output generated from. So that utility we are going to be give. We will see the satisfactory level of the customer and the usage of the output we have submitted, whether it is helpful or not. If the output generated is not useful, then we have to think about what process makes to convert the given state into a new state. That new state will be part of the successful journey, and that state is actually required for the end user who are looking for. That utility we need to provide to the end user. So if you take the vacuum world, a application where we have the two rooms and comprising the dust, and we are providing a resource called vacuum cleaner. That vacuum cleaner has to navigate in room 1 and room 2 and need to make the clean by sucking the dust present in both the rooms. And finally, the rooms must be clean. This is the application where we have the accessibility of the rooms, and room environment can be deterministic, and the things can be episodic, and things can be static or dynamic, and the where the environment can be discrete and continuous. In which application we need to utilize the vacuum cleaner to navigate between room 1 and room 2 and see the environment through the sensors identify the dust. If it is present, so you have to apply the operator called suck. Suck the dust and make it clean. So here the perception is to see for the dust and action is suck if the dust is present. The goal is the two rooms must be clean. What is the environment? Here environment is we can see the two rooms with the walls, we can see the floors, we can observe the dust on the floor if it is present, and the cleaner to navigate from one room to other room and see for the dust if it is present, suck it with the cleaner what you present. So let's see that this particular PAGE, perceptions, actions, goal, and environment, is the theme in the AI with respect to the agents and environments. Thank you all.